Hey guys, Mary, and welcome back to Study Journey. Welcome back to the Recursion series, but this is going to be the first episode of the Recursion Problem Set series. So in this episode, we're going to be going over again the MIT OpenCourseWare 6.0001 problem sets, and this is going to be the recursion series. So it is one of the problems in the problem set. Remember in the previous episodes, we took a little break from that to learn what recursion is. Now we're going to apply it to this problem set. So without further ado, let's get into the video. Okay, so now we're going to start on problem set 4 in the Introduction to Computer Science and Programming in Python, which is the 6.0001 in the MIT OpenCourseWare Problems. So I'm going to first download problem set 4 and download the file. Now I'm going to move it to my folder CS Practice, which I have already done. And as we can see, I'm going to open it and it has a few things that they already gave you. The first thing is, let's open up the instructions. So it says this problem has two parts. The first part allows you to practice thinking about problems in a recursive fashion, taking advantage of the idea that one can reduce a problem to a simpler version of the same problem. So as we can see in the previous episodes, we took a little break from these problem sets because we learned about recursion. So now we're going to apply that knowledge in problem set 4. So it says in ps4a.py, you will write a recursive function that takes as input a string and figures out all the possible reorderings of the character in the string. And then it says that the second part will give you experience in thinking about problems in terms of classes, each instance of which contains specific attributes as well as methods for manipulating them. And in ps4b.py, you will use object-oriented programming to write a Caesar cipher. And in ps4c.py, you will use object-oriented programming to write a very simple substitution cipher. As always, please do not rename the files we provide you, and you will need to keep words.txt and story.txt in the same folder in which you store ps4a, ps4b, and ps4c. So as we can see in our folder, there's ps4a, b, c, and then the story.txt and the words.txt. So we're just going to keep these all in the same folder. And then finally, please consult the style guide as we will be taking point deductions for violations. So for this PSET, style guide number 678 will be highly relevant, so make sure you start using those before starting the PSET and again before you hand it in. So this is for the students, as we can see, so that's not going to apply to us for now. So in today's episode, we're going to be starting on part A, or ps4a.py. And it says that a permutation is simply a name for a reordering. So the permutations of the string ABC are ABC, ACB, BAC, BCA, CAB, and CBA. So basically all the ways you can rearrange these three letters. It says that note that a sequence is a permutation of itself. For this part of the PSET, you will need to write a recursive function, get permutations, that takes a string and then returns a list of all of its permutations. And it says that you will find this function helpful later for PSET for part C. And a couple of notes on the requirements: recursion must be used, and global variables may not be used. Additionally, it is okay to use loops to code the solution, but the order of the return permutations does not matter. So it says for us to avoid returning duplicates in the final list. And this is telling us basically that we're going to be practicing using recursion, so use it. And it gives us a suggested approach. It says in order to solve any recursive problem, we must think about at least one base case and a recursive case or cases. And we can think of our base case as the simplest unit we have for this problem, so for which determining the solution is trivial and requires no recursion. For this approach, our base case is if sequence is a single character and there's only one way to order a single character. So if sequence is longer than one character, then we need to identify a simpler version of the problem that, if solved, will help us easily find all permutations for the sequence. And the pseudocode below gives one approach to recursively solving this problem. So here's the pseudocode of how to solve it. So given an input string sequence, the base case is if the sequence is a single character, then there's only one way to order it, so we just return the single case. And otherwise, the recursive case is we had to first suppose that we have a method that will give us a list of all permutations of all but the first character in the sequence. So think recursion. And then the permutations of all characters in the sequence would be all the different ways we can insert the first character into each permutation of the remaining characters. So if our word was bust, then we could use the letter B and hold it out, and then for the rest, we get the different types of permutations, and then we just put B in all of the places in front of it, and then same for the first one, the second one, the third one, etc. So it tells us to implement the get permutation sequence function found in ps4a.py according to the specifications in the doc string, and write 3 test cases for your function in comments under if name main, and each test case should display the input, expected output, and an actual output. And so see that for an example. So this is all the instructions for part A. So now I'm going to put this to one side and actually open ps4a.py. Okay, so putting them side by side, we can see that here is the code for the definition for permutations. So here's some instructions right here. It says to enumerate all permutations of a given string. So sequence is an arbitrary string to permute, and assume that it is a non-empty string. You must use recursion, and it returns a list of all permutations of sequence. And then here in the main, here is an example of how we can write out a test case. So let's get started on the definition for permutation. Well, as we can see, we can just follow the pseudocode because it basically tells us what to do. So given an input string sequence, so that is what it is right here. So the parameter right here is sequence because it takes in the sequence. And then I'm going to delete this pass line. And I'm going to, like always, change these to tabs if they're not already tabs. So they're all the same. And then now we can get started. So the base case is if the sequence is a single character, then there's only one way to order it. So that's just a string, so we just return a string list containing sequence. So if the length of the sequence is 1, then we just return it. So return sequence. Otherwise, if it is a recursive case, so else, then what we do is suppose we have a method that can give us a list of all permutations of all but the first character in the sequence. So first of all, we're going to be returning permutations. So whatever we do, in the end, we must return the permutations. So what is the permutations? Well, we have to define it first. So I'm going to define permutations, and it's just going to be an empty list for now. And now that we have this, so the first thing we must do is take out basically the first character, as we can see in this example right here. So all but the first character in sequence. So how we do this is let's just define what the first character is. So I'm going to say sequence 0. So the index is 0, then that's the first item. So that is just going to be in the sequence the index of 0. So that is saying the first character in the string sequence. And then from here, the sub-permutations list is just going to be everything but the first one. So it's just going to be the get permutations. We're going to call that. So it's going to basically do it again. So as we can see, to find these permutations, we have to call this permutation function over and over. So that's what we're doing right here. This is using recursion, get permutation, and it's going to take in from the sequence from the first one forward. So that's what the colon means right there. And from then, we can actually write the part for the permutation. So for the original string, in sub-permutations, we're basically going to be inserting the first character into every single one of them, and then inserting the next character, etc. So how we do this is for j in range, the length of the original string plus 1 the result is going to be what the character is before, so the original string, and then it's going to be the one before J, so colon and then J, and then plus sequence 0, so the first character, and then plus the one after. So J colon. And that is going to be the result. And then we're just going to append it. So permutations dot append, and we're going to be appending the result. And now that we have this, the last thing we have to do is actually return the permutations. Okay, so we basically wrote a base case from our pseudocode over here. So now what we have to do is actually test it to see if it works. But it doesn't give us a test case in this problem set, and it tells us that we have to write it ourselves. So in the next episode, we're going to be writing out the test case and then testing our code.